are dealing with 6.1 still, so it's the same concept, just more diverse examples. So the first one is example 4, which is talking about two functions that intersect in more than two spots. So the one that they use is you have, something like this, and a line coming through here. And we're trying to find the area of the region between the graphs. So you see that it intersects here, here, and here. So 3 spots. And we're trying to find this and this. So this is pretty simple and straightforward. We'll call this f of x and this line g of x. So what we want to do is we first want to find all the intervals. So we want to find all the x's where those cross. So we're actually going to set f of x equal to g of x to find all those. So you'll be given A, B, and C, so 1, 2, and 3 intersections. And we're going to set up a function like this. So we're going to start with A to B, and that's going to be f of x minus g of x. And then we're adding another section from B to C. We go A to B, B to C, and this time we're doing g of x minus f of x. So the reason we do that is because this g of x is now the top boundary of this area. So this second equation is this area. This first equation is this area. So we always are subtracting the lower boundary from the upper boundary. So we always have to start off with the upper boundary. So just be careful of that while you're doing problems like that. Next we have example 5. So this is example 4. Example 5 is a little different. So they have something like this, and we're trying to find the area inside here. We have 2 intersection points, so we're just doing from A to B. We're just doing 1. So the thing is, if we just do if we choose it for x, right? So this is x, or x1, x2, right? The problem is we're going to cut off, if we bring this x1 down, we're only measuring that area, but we need to measure this part as well. So one way we can do that is, instead of taking the x values, we can take the y values, right? So this is going to be y1, this is going to be y2, and our whole area that we're trying to find is within those 2 side parameters, I guess is what we'll call it. So instead of using x values, we're going to set A and B equal to y, where they intersect on the y-axis. So we're actually going to set f of y equal to g of y to find those. And so this looks like, so if we have the x minus y, if this is our function, we can change it to be x equals y plus 1. So now this is our f of y, right? Because we're plugging in a y value to get another value. This is our f of x. Sorry. Yes. Okay. So now we're going to use the same equation we have been using, but A and B are y values, and we're using g of y minus f of y. So again, this is now, so if this was originally, let's say this was f of x, this is g of x. This is now, this is also represented as f of y, g of y. So originally, f of x, if we take it in terms of the x values, f of x is on top, right? So we would set it up as f of x minus g of x. But when we start taking it from the y, this is the top, so we're flipping it like this. This is the top, this is the bottom. So now we're using g of y minus f of y, because g of y is the top. So that's why we have to use this instead of having f of y minus g of y. So again, A and B for example 5 problems. A and B are y values. G of y and f of y, they are functions, functions that look like this, not this. So set x equal to some function. And again, we're doing the top minus the bottom. Top boundary minus the bottom boundary. It's very important. You'll get something really wonky if you do it any other way. Again, we use example 5 when our x's, if we put down our x1 and x2 values, if there is some part of our curve that is outside that boundary, then we have to use y instead of x. So we'll use something like example 5 instead of something like example 4. Example 4 is for when you have multiple x's or multiple intersection points. We're doing 16 through 21 today. Yeah, so that should be pretty straightforward. If you have any questions or need to go over any problems, please let me know and I will help you out as best as I can.